Hello everyone, welcome to my class. Today I am going to explain about amines. This chapter which is present in second year organic chemistry as amines, cyanides and isocyanates. Now I am going to explain about amines, classification, nomenclature and preparations of amines. So first let us discuss about classification of amines or what is the general formula of amines. Here this is the general formula of amines, alkyl amines. Here NH2 is called as amine, whereas NH3 is called as ammonia. Here classification of amines, here under the classification of amines, ammonia, in this ammonia around the nitrogen, 3 hydrogens are present. When it is one hydrogen which is replaced by the one alkyl group, then this amine is called as alkyl amine. Now around the nitrogen, here one alkyl group is present, hence this amine is called as primary amine. Here, this primary amine, in this primary amine, one hydrogen, if it is replaced by the another alkyl group, then which produces the dialkyl amine. Now, in this dialkyl amine, around the nitrogen, two alkyl groups are present. Hence, this amine group is called as secondary amine. And in the secondary amine, if one of the hydrogen is replaced by the alkyl group, then which produces the trialkyl amine. In this one, around the nitrogen, total 3 alkyl groups are present. Hence, this amine group is called as tertiary amine. So, in primary amine, around the nitrogen, one alkyl group is present. In secondary amine, around the nitrogen, 2 alkyl groups are present. In tertiary amine, around the nitrogen, 3 alkyl groups are present. So, these are the primary amine, secondary amine, tertiary amine. In all the amines and ammonia on the nitrogen which contain one lone pair of electrons. So, here which containing the one lone pair of electron, this is tertiary amine. So, when it reacts with the alkyl halide, in alkyl halide, R is a plus whereas X is a minus charge. So, this nitrogen will donate the electrons to the R plus charge, then it produces the quaternary ammonium salt. In this quaternary ammonium salt, nitrogen will get the plus charge, whereas halogen will get the minus charge, because generally nitrogen could able to make the bonds only with the 3, but here total 4 bonds are present, so nitrogen will get the positive charge. So total amines are 4 types. One is primary amine, secondary amine, tertiary amine, another one is quaternary amine. So here if alkyl groups are R groups are alkyl groups, then these amines are called as aliphatic amines. If R groups are aryl groups, then these amines are called as aromatic amines. So this is the classification of amines. Next, coming to nomenclature of amines, according to the IUPAC nomenclature, primary amines generally represent as derivatives of corresponding alkanes, whereas secondary and tertiary amines are regarded as N-alkyl substituted derivatives of amines. For example, if you see in this compound, only one methyl group is present, that means one carbon is present. So if one carbon is present, according to IUPAC nomenclature, the name is called as meth. And here, which is called as NH2, as according to IUPAC nomenclature, this NH2 is called as amine. So hence this name is methanamine. Whereas here this compound containing 2 carbons, hence this according to IUPAC nomenclature, if any compound containing 2 carbons, then that compound is called as eth or ethane. Now which containing the amine group, hence this one is called as ethanamine. Whereas these two are primary amines. So hence we are writing as amino derivatives of corresponding alkanes. But here in this example, here it is the secondary amine. So around the nitrogen, 2 alkyl groups are present, hence it is called as secondary amine. So in the secondary amine, we have to write as a N-methyl derivatives. So here we are writing N-methyl, and here total 2 carbons are present, hence N-methyl ethanamine. And here, for example, if you see in this compound, here the branches are present. So whenever we give the numbering 1, 2, 3, here at the second place, this is the methyl group is present. So 2 methyl, total how many carbons are here? Straight line, 3 carbons are present. If 3 carbons are present, then this is called as propane. And here amine group is present. At one place, amine group is present, hence 1 propanamine. Like this, we can write the nomenclature of primary amines as well as secondary and tertiary amines. Next, coming to the aromatic amines, these are the few examples of aromatic amines. The best example for aromatic amines are aniline. Aniline is nothing but NH2 group, which is the substituent on aromatic ring. And here this is called as N-methyl aniline. N-methyl aniline. And here, if you see in this compound, here this is called as orthotolidine. Orthotolidine is nothing but here, orthotolidine is nothing but generally if on the benzene only methyl group is present, then this compound is called as toluene. But this compound which is containing both amine group as well as methyl group, hence this compound is called as tolidine. And here two groups are substituted at 1 and 2 position, hence this name is orthotolidine. Whereas here this compound is called as diphenylamine. The short form is DPA. And here this compound is called as triphenylamine because which containing total 3 phenyl groups are present. Hence, this name is triphenylamine. This short form of this compound is TPA. So these are the few examples of aromatic amines. And coming to the stereochemistry of ammonia or any amines, generally on the nitrogen which containing one lone pair of electrons and which could able to make the bond with the 3 alkyl groups or 3 hydrogens. So here this hybridization is sp3 hybridization. The bond angle should be 109 degrees, but here because of the repulsions between the lone pair of electrons as well as bonding pair of electrons, the bond angle will be reduced, and instead of having the tetrahedral geometry, which possesses the pyramidal structure because of having the nitrogen lone pair of electrons as well as bonding pair of electron repulsions. Here instead of having the tetrahedral geometry, it shows the pyramidal geometry, as well as the bond angle also will be reduced, that is the bond angle is 107 degrees. And here because of the nitrogen which containing one lone pair of electrons, hence which act as a Lewis base as well as nucleophile. Lewis base is nothing but the compound can able to donate the lone pair of electrons or also act as a nucleophile. So these are the structure of the or stereochemistry of the ammonia or amines. And coming to the preparations of amines, the first preparation is from alkyl halide. So here alkyl halide, here we have taken as ethyl iodide. When it reacts with the ammonia, as we discussed earlier, on the nitrogen which containing one lone pair of electrons, hence it acts as Lewis base or it can act as nucleophile. Base is nothing but it can donate the, it gives electrons to the another substance which is a deficiency. So here in alkyl iodide, alk is a plus charge, whereas iodide is having the minus charge. Hence, whenever it gives electrons to the R group, because which is a deficient, simultaneously this iodine is eliminated as a I minus. Here, after donating its lone pair of electron, nitrogen will get the positive charge. Hence, to neutralize this positive charge here, nitrogen which is taking this hydrogen bonding electrons and which liberates as a H plus. Here H plus and I minus eliminate as a HI. So finally here one of the hydrogen is replaced by the ethyl group and which produces the ethyl amine. Now in this one Around the nitrogen, only one alkyl group is present, hence it is called as primary amine. Whereas now this ethylamine again further reacts with the alkyl iodide or ethyl iodide, again which nitrogen which donates electrons to the alkyl group and which produces the diethyl amine. Here also first which liberates donates its electrons to the ethyl group and nitrogen will get positive charge, and to neutralize this positive charge this nitrogen will abstract this bonding pair of electron. So from here H is liberated as a H plus, whereas from here I is liberated as I minus, H plus and I minus liberates as a hydrogen iodide. Now this diethylamine further which reacts with the ethyl iodide, and this hydrogen further replaced with the ethyl group and produces the triethyl amine. Now this triethylamine further reacts with the ethyl iodide, because here on the nitrogen which containing the lone pair of electron which donates electrons to the ethyl group and produces the quaternary ammonium salt. Here whenever nitrogen makes the around makes bonds 4, then nitrogen will get the positive charge. So these are the preparations of primary, secondary, tertiary, quaternary amines by using the alkyl halides. And next preparation is Gabriel phthalimide synthesis. In this Gabriel phthalimide synthesis, the reactant is phthalimide. In this phthalimide, first when it reacts with the potassium hydroxide, this is the base. Whenever it reacts with the base, here from here H plus, from here OH minus liberates as a water molecule, and here this H plus is substituted by the K plus. Now this compound is called as potassium phthalimide. This compound is called as potassium phthalimide. Now when this compound, when it reacts with the alkyl halide, in this alkyl halide R will get plus charge, whereas halogen will get minus charge. So here nitrogen which is having the minus charge is nothing but which is having the one lone pair of electrons which can able to donate electrons to the R group. So simultaneously this X is liberates as a X minus. This X minus and K plus liberates as a Kx. And here this alkyl group is substituted at the nitrogen and produces the N-alkyl phthalimide. Now this N-alkyl phthalimide undergo hydrolysis. Then what will happen? This amide group linkage will become break, and this bond also will become break. And here because of hydrolysis, one OH group will substitute here, one OH group will substitute here, one hydrogen will substituted on the nitrogen. So finally which produces the phthalic acid as well as which produces the amine. And here the amine structure which depends upon the which alkyl halide we have taken, which depends upon which alkyl halide we have taken. Suppose if we have taken methyl halide, then which produces the methyl amine. Suppose if we take here ethyl halide, then we will get here ethyl amine. Like this, we can prepare the primary amines by using the Gabriel phthalimide synthesis. In this Gabriel phthalimide synthesis, first starting reactant is phthalimide. When it reacts with the potassium hydroxide, which produces the potassium phthalimide. Further, when it reacts with the alkyl halide, so finally which produces the N-alkyl phthalimide, which is further undergoing to acid hydrolysis, then which produces the phthalic acid as well as primary amine. Next, third preparation is Amines bromamide reaction. In this Amines bromamide reaction, the starting reactant is amide. Amide is nothing but C double bond O NH2. This linkage is called as amide. This amide, it reacts with the bromine in the presence of 4 moles base, then which produces the amines. If you see the difference between amide and amine, only the difference is we have to remove this C double bond O group from reactant to product. So in this Amines bromamide reaction, the starting reactant is amide, whereas final product is amines. and the byproducts are K2CO3 and KBr and water. Coming to the mechanism of this Hoffman bromide reaction, amide, when it reacts with the base, that is OH minus, here in this OH minus in NH2H place liberates as a water molecule. Nitrogen which liberates as a H plus group, hence on the nitrogen will get the minus charge. Now this one when reacts with the halogen, in this halogen one bromine will get Br exist as a plus charge, another Br exist as a minus charge. Now this nitrogen which is having one lone pair of electron which donates electrons to the bromine, so simultaneously which liberates as a Br minus. So which finally which produces the N-bromoamide. Now in this N-bromoamide again further reacts with the base. This base again takes this proton here from this N-bromoamide. So finally which produces this compound. In this compound nitrogen is having the minus charge because here from here H is liberated as H plus, hence nitrogen will carry the minus charge. Now this compound is undergoing to rearrangement. Here nitrogen which is having one minus charge is nothing but having lone pair of electron. It donates its electrons to here to this bond. So simultaneously here this R group along with this bonding electron which shift towards to the nitrogen. Simultaneously this Br is eliminated as a Br minus. First nitrogen which gives its lone pair of electrons to this bond, then simultaneously this R group along with this bond which shift towards to the nitrogen, then simultaneously this Br is eliminated as a Br minus. Like this molecule is undergoing to rearrangement and produces the O C double bond O double bond C double bond N and R group. So finally it will produce the isocyanate. This is the structure is called as isocyanate and which liberates the Br minus. Now this isocyanate undergoing to hydrolysis, and here this carbon will get OH group. Whenever which undergoing to hydrolysis, then this carbon will get OH group and nitrogen will get H. Finally, which produces the carbamic acid. Now on further reaction with the base, now this group will be undergoing to break and produces the alkyl amine, and this group is eliminated as a CO2. So like this, by this method in Hoffman bromamides reaction, amide when it reacts with the bromine in the presence of base can prepare the primary amines. So in this mechanism, amide first when it reacts with the base, it takes the abstracts the proton from the amine and produces the N minus charge. When it reacts with the halogen, and here which produces the N bromoamide. Now this N bromoamide again further reacts with the base. That base will abstracts the proton here. Again nitrogen will get minus charge. Now this compound is undergoing to rearrangement taking place. So here nitrogen will donate its electrons, bonding electrons to here. Simultaneously R group along with the bond shift towards to the nitrogen. Then simultaneously this halogen eliminates as a Br minus. So finally here isocyanate compound will form. This isocyanate and on hydrolysis, basic hydrolysis, which produces the primary amine. So next preparation method is Schmidt reaction. In the Schmidt reaction, the starting reactants are carboxylic acids, or CO2H is called as carboxylic acid and reacts with the N3H is nothing but this is called as hydrojoic acid. This is the structure of N3H. Nitrogen, here this nitrogen is having the minus charge because this nitrogen is having only two bonds, hence which is having the minus charge as well as which is having one lone pair of electrons. Whereas this nitrogen which is having the total four bonds, hence which is having one positive charge, and this nitrogen here two bonds and this is the one bond, hence no charge. but which is this nitrogen also have the one lone pair of electrons. So this is the structure of hydrojoic acid. This carboxylic acid, when reacts with the hydrojoic acid in the presence of concentrated H2SO4, then which produces the primary amines. And also the byproducts are carbon dioxide and nitrogen. Coming to the mechanism of Schmidt reaction, in this reaction, first acid, when it reacts with the acid, that is H2SO4, in the presence of this strong acid, then what will happen here? This H plus will attack here. This, so because this oxygen is having the lone pair of electrons, hence which takes, by giving its electrons to the H place, then which makes the bond here. Simultaneously, this pi bonding electron shift towards to the oxygen, then carbon will get plus charge here. Now, when it reacts with the hydrojoic acid, that is N3H, in this N3H, last nitrogen which is having the minus charge, so which donates its electrons to the carbon because which is deficient, and makes the bond between carbon and nitrogen. The remaining structure is same, RCOH, here nitrogen, double bond N plus double bond NH. Now in this, here this hydrogen bonding electrons which gives to here, and simultaneously this pi bonding electron shift towards to this nitrogen, because this hydrogen donated its electrons here, simultaneously this pi bonding electron shifted to here, this nitrogen. So RCOH nitrogen, because this pi bonding electron shifted to this nitrogen, hence this nitrogen will get minus charge, whereas here nitrogen which remain as it is positive charge, because around the nitrogen here which containing total 4 bonds here, hence nitrogen is having the plus charge, but here this bonding electron shifted here, hence it will get triple bond, and here this nitrogen which is also having the lone pair of electrons. And here the same carbon, if two OH groups are present which is unstable and undergoing to eliminate as a water and produces the C double bond O. And here, and again C eliminate as a water, and in this water again it reacts with the H plus. This H plus will abstract here because nitrogen is having the minus charge, hence which produces the NH compound. And here finally by forming this compound, this group will eliminate as a nitrogen by taking its bonding pair of electrons, so which eliminate as a nitrogen. So finally which produces the RC double bond O NH plus, because this nitrogen bonding electrons taken by this compound, this nitrogen, hence which get the plus charge on the nitrogen. So to neutralize this the charge, again it takes its bonding electrons. So finally which produces this nitrene or C double bond O nitrogen. Here which containing the two lone pair of electrons. Here with this compound is undergoing to rearrangement. This bonding electron shifted towards to here. Simultaneously, this R group along with the bonding electron shifted towards to this nitrogen. And finally, which produces the alkyl isocyanate. As earlier we have studied in Hoffman bromide reaction, here also alkyl isocyanate is which is produced, and further hydrolysis which produces the amines. So similarly, after rearrangement, this compound will produces the alkyl isocyanate, and further hydrolysis with this compound. In this method also we can prepare the primary amines. So this is about complete Schmidt reaction. In this Schmidt reaction, the starting reactants are carboxylic acid when reacts with the hydrojoic acid in the presence of concentrated H2SO4, which produces the primary amine. And coming to the mechanism of this compound, carboxylic acid, when it reacts with the acid, here oxygen which is having the lone pair of electron which takes its H place, and here simultaneously pi bonding electron shifted towards to the oxygen, so carbon will get the plus charge. If this is the hydrojoic acid structure, so which makes the bond between the carbon and nitrogen, hence this compound will form. So here this bond shifting of bonding electrons here from one place to another place, finally we will get this one. Here same carbon, if two OH groups are having two OH groups are unstable, which liberates as a water molecule. So finally which liberates this compound. And also here this by taking its bonding electrons, this compound is eliminates as a nitrogen and which produces this compound. And here nitrogen is having the plus charge. To neutralize this charge, which takes its bonding electrons and finally which produces the nitrine. This nitrine undergoing to rearrangement. Because of the rearrangement, this pi bond lone pair of electrons shifted to here. Simultaneously this R group along with this bonding electron shift towards to the nitrogen and produces the alkyl isocyanate. And finally on hydrolysis which produces the primary amine. In Hoffman bromamide reaction, the intermediate is isocyanate, whereas here also in Schmidt reaction also the intermediate is alkyl isocyanate. In the two reactions, the final products are primary amine. And the last preparation of amines are reduction of amide. Here this is the CH3 C double bond O NH2. C double bond O NH2 is called as amide when it is reduced in the presence of the reducing agent lithium aluminum hydride. This is the strong reducing agent. In the presence of this reducing agent, what will happen here? Reduction is nothing but removal of oxygen or addition of hydrogens are called as reduction. Here total four hydrogens will add here, and this oxygen is eliminated as a water molecule. Finally this C double bond O group is converting into CH2. So finally it produces the ethanamine. Similarly here in this compound, this one also undergoing to reduce with a strong reducing agent, that is lithium aluminum hydride in the. So here also which reacts with the 4 hydrogens or 2 moles of hydrogens. So therefore here first 1 mole of hydrogen will add here and produces the alcohol, and second 1 mole of hydrogen will add, that OH group also eliminate and produces the CH2. So this is the N-methyl ethanamine. So like this we can prepare the different types of the amines by different types of methods. So today we have discussed about nomenclature and classification of the amines and stereochemistry of the amines and preparations of different preparation methods of the amines. I hope you are all understood of the what are amines and preparation methods of amines. Thank you for your patience listening.